Hello everyone, welcome to Math Tired Club, where we make all those hard things in math very easy. Don't forget to turn on notifications so that whenever I upload a new video, you will get notified immediately. Don't forget to also like, subscribe, and comment. And thank you so much for your support and good comments. It really gives me a lot of enthusiasm to make better videos every time I make a new video. Thank you so much, everyone. So in today's lesson, we're going to talk about graphing rational functions of the form y is equal to ax plus b over cx plus d, in which c does not equal to 0. Okay, I'm going to teach you a way that you can graph these very easily. Okay, so the first thing that we have to start with is that there are some things that you need to find. Okay, the first thing that you need to find is the vertical asymptotes, and the other one is the horizontal asymptote, and then the x-intercept and the y-intercept. So these are the things that you need to pay attention to, okay? So I'm gonna start with an example, and I will be back with my example and the coordinate plane. Okay, ta-da! I'm back with my example and also with a set of rules that is going to help you to very easily be able to graph anything that is given to you in rational form. I will also make other videos of other types with different types of like horizontal asymptotes, maybe slants, maybe holes, and all those things. And I will link them in the description box below. Okay, and I'm trying to explain things as easy as possible. So if you want to know the reasons of all these things that I've written down, I will also upload another video on that so that you can actually understand why would these rules happen. Okay, so first things first. First, I'm gonna start with the meaning of asymptotes. Guys, asymptotes are those lines, vertical or horizontal, that the graph is gonna get so close to, but it's never gonna go through them. And those are the lines that the graph is never gonna cross those lines, okay? So the first thing is the vertical asymptote. The vertical asymptote is the asymptote that the graph is never gonna go over. And also, it's going to be whatever is in the denominator should not equal to 0. I mean, if you relate it to the domain of the function, that also makes sense. So if you say whatever is in the denominator, okay, 1 second. So whatever is in the denominator, which is x minus 1 here, is equal to 0, then x is going to be 1. This is going to be your vertical asymptote, okay? So the vertical line that the graph is never going to go through, that is going to be called your vertical asymptote, okay? So over here, x is equal to 1 is going to be the vertical line that the graph is never going to go through. So I'm going to start graphing that line, okay? So I'm going to graph the line x is equal to 1, and I'm going to graph it dotted because I want to show that the graph is actually never going to go through this line, but it's going to get so close to this line. Okay, so that's my vertical asymptote. About the horizontal asymptote, just guys, pay attention. There are some rules. I mean, these are not like rules. They all have like reasons, and I'm gonna upload a video on them, and I'm gonna link it in the description box below. But it's very easy if you want to just graph them very easily to know these rules. So if the top degree is greater than the bottom degree, then there are not going to be any horizontal asymptotes, and you have to check for a slant. And if the top degree is equal to the bottom degree, then the horizontal asymptote is going to be found by dividing the leading coefficients. So over here, the power of x here is 1, and the power of x here is also 1. So they have the same degree. So what the horizontal asymptote is just the division of the leading coefficients of x. So over here, it's going to be, it's horizontal, so it's going to be shown by y is equal to 2 over 1, because the coefficient of the leading term over here is 2, and the coefficient of the leading term here is 1. So 2 over 1, that is going to be 2 is going to be my my horizontal asymptote, okay? And then I'm going to graph it, of course, dashed and dotted, because the graph is never going to go through it. It's just going to get so close to it. So y is equal to 2 is going to be this line over here. And I'm going to graph it dashed and like this. Okay, so the next step for me is to find the x-intercept. X-intercept is a point in which y is 0. So if I substitute 0 for y, it is going to be 2x plus 1. So it's going to be 2x plus 1 over x minus 1 is equal to 0. So if you just do crisscross here, you will see that this part is going to get multiplied by 0, and this part is going to get multiplied by 1. So it's going to be 2x plus 1. Okay, I have to write it on the top. So it's going to be 2x plus 1 is equal to 0. So then x is negative 1 over 2. So the x-intercept here is going to be negative 1 over 2 and 0, okay? For the y-intercept is a point in which x is 0. So this is what I'm going to have. I'm going to substitute 0 for x, and I'm going to find y for that. So it's going to be 1 over negative 1. That is just negative 1. So the point is going to be 0 and negative 1. Okay, so I'm going to show these points on my graph. So negative half and 0 is going to be here. Let me choose another color for you to be able to see it clearly. So negative half and 0 is going to be here, and 0 and negative 1 is going to be here. So the question here is, how is my graph going to be like around these asymptotes? Is it going to be, I mean, in this example, since I have found the x-intercepts and the y-intercept, is much easier to actually kind of guess, but I'm going to show you a way so that you will not make any type of mistake. I'm going to be back with the sign diagram of this graph. So ta-da, I'm back with the sign diagram. Guys, I also have a video on sign diagram. I will link it in the description box below. You can check that out. Other than sign diagram is something that I think everyone needs to know. But if you don't want to work with sign diagram, you can just substitute random numbers over here, such as, for example, in this part, you can substitute like -2, -3, and see how the graph is moving. And by substitution of some points, you can get the behavior of the graph and you can guess it. But sign diagram is going to be a much easier way for you to be able to kind of go with it. So I'm telling you, if you don't want to go with sign diagram, just substitute some random points over here and then substitute some random points over here so that you can actually guess how the graph is going. So look, I have found the zeros of the thing on the top of the equation on the numerator, and then the denominator, it's -half and 1, okay? So if I want to do the one on the top, this is going to be the 0. Before the 0, it's going to be the opposite of the leading coefficient, so it's going to be negative, and after that, it's going to be whatever the sign of the leading coefficient is. And over here, it is going to be the opposite before that, and after that, it's going to be whatever the leading coefficient sign is. So if I multiply these to get the whole thing, it's going to be positive and negative and positive, okay? So this is what the this sign diagram is telling me. So from negative infinity, okay, to negative half, my graph is on the positive side, okay? So I'm going to go with that, and I'm going to be like from negative infinity to half, which is over here, guys. This is half. My graph is on the positive side, so it's going to be on this. So it's going to get so close to the asymptotes, and then it's going to be over here. As you can guess, I mean, if you want, you can just go with this motion and just continue this like this, or you can look at your sign diagram and do it precisely. And from negative half to 1, my graph is gonna be negative, and you know that this is the 0. So if it wants to be negative, it's going to go below this, and it's going to get so close to the asymptotes, but it's never going to go over that or cross it. And from 1 to positive infinity, my graph is on the positive side. And you know that since it's not going to go over the asymptotes and everything, I'm going to have a graph that actually looks like this. Okay, and if I'm not sure how the graph is moving, I can actually substitute some numbers greater than 1 over here and see what their y's is going to be. But this is going to be good enough for you to be able to graph it. As I said, if you want, you can just skip the sign diagram and just substitute some random numbers over here to know how the graph is moving. But with the sign diagram, you can actually do it way like more professional and faster. So guys, I will also have other examples with like top degree being greater than the bottom degree, or having like no horizontal asymptotes and having a slant, or like the top degree being less and everything. I will link them in the description box below. Thank you so much for watching this video. Thank you so much for supporting me again. Guys, don't forget to like, subscribe, and comment, and also turn on notifications so that you will get notified immediately when I upload something. Again, thank you so much for your support. Have a great day. Bye.